Alright, next size up is a 230 milliamp test light. So let's plug this into the 5-volt reference. See, it does light up pretty brightly. And if we unplug it, you see now we can measure the current pretty reliably. So we'll re-zero the amp clamp, plug in our test light, we should see about 0.2 amps. So where's that current going? That's the question of the day. Can we separate these wires out and then use the amp clamp to track it down? Maybe. Alright, so first measurement is around the bundle of wires that have the fatter pins. So amp clamp is zeroed out. I'm going to connect my test light right there. And look, minus 0.2 amps. So all the current is going this way through the amp clamp to ground. Okay, so it's coming in on this wire into the PCM. But my question is it making a round trip through one of the sensors or one of the harnesses? Or is it just going through the computer and out here? So let's put the amp clamp around the second bundle of wires and see what that reads. Alright, here we go. Amp clamp is re-zeroed. Oh, let me unplug that. So it didn't change. Right, test light's on. Put it over here. Test light is off. Zero change. So either the current's going in and out on a pair of these wires, or it's just all going through the engine computer. Very strange. Alright, so I actually pinpointed exactly which ground wire the current is leaving the engine computer. That one right there. So let's do a resistance measurement between the 5-volt wire and the and that ground with the computer unplugged. That'll save us some time. Alright, here we go. So pin 72, pin 104. Look at that reading, 2.3 ohms. So this computer's junk. On the 5-volt reference is shorted to ground 2.3 ohms. Let's try a different computer. I think this is the eBay one, the one that didn't blow up yet. Let's try the same exact measurement. You can see the reading. Pin 72 to 104. 203 ohms. Big difference. Let's try the original computer. See if that one's shorted out. So my question is, the car ran for 5 minutes and then cut out. And that air intake valve, the resistance was only 160 ohms instead of over 1 kilo ohm. Could that have stressed out the 5-volt reference for 5 minutes and it couldn't handle it and it burnt out the engine computer? That's very possible. So I'm going to leave that wire cut for now. We're going to find out which computers are good, which computers are bad, just with that 1 ohm measurement. Install the good computer, see if the car talks, see if we can get it running, and leave that wire cut for now. And if the car runs for, 10, whatever, half an hour, and just sets a code, then we'll, it'd be nice to measure the resistance of that potentiometer on a known good car, which I don't have on the lot right now. But it looks like that low resistance in the potentiometer is stressing out the 5-volt reference circuit. I mean, can you calculate how many amps are going through there? Sure. Just use Ohm's law. We can do that. Okay, last one. Pin 72. Sure the meter's in the picture. To 104. 1.4 ohms. So is this one burnt out too? So the only good one, it looks like, is this one. Let's just measure it. You guys see the meter? No. It's the exact same measurement. 203 ohms, repeatable. Wow. Alright, so the only remaining good computers plugged in. Do we want to do any checks just to be 110% sure that this computer isn't going to burn out? What else can we check? All the 5-volt sensors, right? When we unplugged them all and nothing made a difference, it was still at 0.9 volts. Wondering what else we can check. None of the other wires are shorted to ground. Could they be shorted to the signal return? I guess we can do some more ohm checks before we turn the key on this computer. Well, I'm going to try it. Let's just turn the key on. See if the check engine light comes on. See if we can talk to this thing. Yep, check engine light's on. So this computer is good. Let's check the voltage on that 5-volt pin. Right here. 5 volts, beautiful. Let's scan it for codes. See if it's setting that intake valve code. So this wire is cut right now. So hopefully we're not overloading the 5-volt circuit. And we'll see if this car starts and runs. I don't know if we can program the key. Somehow the owner did it himself. So let's see if we can get it fired up. Alright, so we got an auto ID. There is the VIN. Obviously it's not correct for this vehicle. I'm not sure we can change that, but we'll try. Let's do a full code scan, see if there's a VIN mismatch, see what the Immobilizer is doing. Alright, let's try to start it. Okay, so Immobilizer is active. Let it clear the codes out. Let's do one more smart scan, see what codes are stored. Alright, so in EOBD2, we have the pending and current intake manifold runner position sensor switch circuit low bank 1, yes. And ECM says those two engine immobilizer system, engine immobilizer system. So B2799, let's get in here. Let's do special function. We can do VIN. Okay, so VIN right. Waste DC automatically for writing the VIN. Check the following conditions. Press OK. Proceed. Engine off. Radio off. Ignition on. Okay. VIN number. That's the current one. You want to input? Let me put in the right VIN. All right. So it wrote the VIN successfully. There it is. 4T1BF3. EK0BU730095. Excellent. And let's see about that Immobilizer. Clear fault memory, yes. Okay. Read fault code. Right there, B2799. Let's see how to program this key. Well, let's just wing it in the Immobilizer. Get in here. Special function. Transponder code registration. New transponder code. Okay. Okay. Move key from cylinder. Okay. Okay. Key you want to program. Okay. The key has already been registered. Nope, not that one. Nope, not that one. Let's read data stream. See if we have a valid key. Select all. Says everything's okay. Let's read some service info. Alright, so when replacing ECM, it says register the ECU communication ID between the ECM and the transponder key ECU. Procedure C. Procedure C is... Where's procedure C here? Procedure... Let me find procedure C. So procedure C says connect pins CG and TC with the special tool. Turn the ignition switch to the on position, leave the vehicle as is for 30 minutes, check that the engine starts. Huh. That's a 30-minute relearn. Okay, let's jump these two pins together. Alright, so pins CG and TC are connected. This is the fourth one in the top row and the fourth one in the bottom row from the back. Right there. Turn the key on. Little cruise control lights blinking, everything's blinking. Alright, 30 minutes. I'll put the battery charger on here. Alright, it's been 30 minutes. Let's see if this thing fires up or not. I'm just going to leave that jumper in. It does. Hooray! We take the jumper out. Check engine lights flashing. Let's shut it off. Uh-oh. Oh, check engine light's still on. Okay, that's good. Key on. Oh, what happened? What happened? Let's scan it for codes. Alright, so we still have 5 volts. Keys on. Let's see what is stored here. Ignition coil A, B, C, D, primary circuits. So all the ignition coils are not happy. What the heck is going on here? Let's clear all the DTCs out. Okay, OBD2. Okay, we got some permanent codes. That's fine. Let's try to crank it one more time. See what happens. I mean, it seems like this thing just died gradually. Okay, ECM, read fault code. All we have is P2016, history, pending, and current. Do we have spark? Let's look at the ignition coil. Alright, let's see here. Ignition coil test light from battery negative. Finds a positive, it's going to line up. Keys on. We definitely have power. Let's check the ground. We find the ground. Test light's going to light up. The ground is also fine. Now we just have the control wires and the IGF signal. This blows my mind. Why would it lose ignition pulse? We can scope it. But it said ignition circuit coil, you know, circuit fault. I'm sure there's no spark. So I'm checking the APP and the TPS. Nice sweep, back and forth. No glitches or dropouts. Let's back out. Smart scan one more time. Ten, 15 codes. Yep. A, B, C, and D. All the ignition coils are setting faults. P0351, 2, 3, and 4. How about that? Well, for lack of a better thing to do, I'm just checking the resistance of the ignition coil trigger wires to ground with the ECM unplugged. It's these 4 wires right here, pins 105, 6, 7, and 8. So let's check this one first. 350. Next one. 345. Next one. 355. And last one. Open circuit. How about that? So which wire is that? That's going to be our white. Looks like just a white wire. Which ignition coil is that? Oh, that's the one that's unplugged. Let's plug that one back in. Three 330. Okay. 350. 345. So no smoking gun here. It's not like a shorted 5-volt trigger circuit or something. 345. 327. So I talked to the customer. He said he already burnt up. How many engine computers do we have? Original, the one that was installed, and 2 spare ones. Out of those 4, 3 were, the 5-volt reference was shorted to ground. And the one that we tried, it ran for 30 seconds and the ignition coil control circuits crapped out. So he's going to get a couple more on eBay. I told him just get 5 things that are like 40 bucks a pop. And we'll see if we can get one that works. This is insane. I've never seen an engine computer go bad on one of these Camrys, but you know, they're getting up there in age, so maybe this is an up-and-coming trend. And what would cause the 5-volt reference to burn out, and then what would cause the ignition coil circuits to go bad? I have no idea. This thing started and ran fine for about 30 seconds, and then started misfiring and completely stalled out. So that's where we are. We're waiting for more computers. I don't have any other thing to check to see what's burning them up. And they're different failures. So perhaps they're just, you know, not bad out of the box. I don't know. I wish I had a known good Camry to check the resistance of that intake manifold valve on that potentiometer circuit. But we don't have that, so we're just going to leave this wire snipped for now. Alright, so on the Camry, while we're waiting for another replacement ECM, I do want to check the resistances on all of the 5-volt components on this, you know, powertrain layout. So I went through the entire wiring diagram again, very meticulously, and wrote down 7 items that I want to check. So the evap PSI sensor, we already checked that, 1.2 kiloohms. The intake air control valve was 168 ohms. That's very suspect. That's the one wire that I cut right here. But we have 7 total, so let me go through all of them. I color coded them, so the orange is the 5-volt reference and the green is the signal return. There's 1, 2, 3, 4, 5 items on this connector, and then the APPs are on the second connector. So I'm going to do all of them, write down all the resistances just to be, you know, make sure none of the components are shorting out. Well, this is interesting. On the TPS circuit, so there's a 5-volt reference, ground, and 2 signal wires. Between the 5-volt reference and ground, 90 ohms. Is that normal? I guess it is for a mechanical potentiometer, and that's less than the you know, intake air control valve, so we might be barking up the wrong tree. But how did 3 computers burn out the 5-volt reference in a row? That's really suspicious. I mean, is there an intermittent short to ground somewhere in the harness? That would be unlike of Toyota to have that problem, but we're just going to keep going here down the list. Alright, so I finished all the measurements. Check this out. On the APP 1 and 2, we have 6 kiloohm resistance between the 5-volt and the signal return. On the TPS, we only have 90 ohms. That might be normal. And on the IAC actuator, about 170, so double the TPS. But none of these should draw, you know, it's still, you know, how much current would be going through the TPS? Well, current would be voltage over resistance, right? So it'd be 5 volts over 90 ohms, or you can just say that's 100 ohms roughly, engineering terms, so 0.05 amps or 50 milliamps. That's still, for a 5-volt regulator, you know, that's a small current. That should not be burning out these computers. So pretty crazy, but we're gonna wait for that next computer. I'm going to take this one out actually, and we'll go from there. So I messaged my friend Keith DeFazio about this 2011 Toyota Camry that's eating engine computers, and he said open one up and show me the burnt driver. So that's what we're going to do. Here is the computer that was installed in the car when they got here. This is not the original. So it's 4 screws, and you just pry on it. No, I didn't put any heat on it. It's just some kind of sealant. So let me finish opening this thing up, and we'll see what's inside. Alright, so here it is. The case is there. Fairly easy to take apart. Doing a visual inspection, I don't see any obviously burnt components or cracked components. So where is the 5-volt regulator? Not exactly sure. We can trace it from one of the 5-volt pins. It's got to be one of these chips, you would think. I mean, the board looks fine, but we know it's not because the resistance between the 5-volt and ground was almost 0. They're about 2 ohms. So maybe Northridge Fix could, Alex could diagnose this quickly by injecting some voltage, seeing a hot spot. We could try that. I think what's up with this chip right here? Is that discolored? Is that cracked? You see that?